Okay, Calc, we're plugging right along. This is section 7.3, which is more on logs. This is basically all the log information or all the log problems that you'll see like on the ACT and stuff like that. This should be really fresh in your mind, hopefully. And there's no backside to these notes, so that's exciting. Just a front side, this should be kind of short, and there's no additional homework assignment. I'm going to embed some problems into this video just to make sure that you guys know what you're doing, and then you're done with that. So the first thing that they talk about is a change of base formula. Your calculator likes to think in log base 10. And I know some of you guys know how to change that very easily on your scientific calculators. You go into, it's the math button, and then you'll go to logs and you can change the base. But on a normal calculator, let's say I don't know how to do that. I don't know how to evaluate log base 4 of 30. Really what this is saying, if I set this equal to x and write that as an exponential function, he will look like 4 to the x power equals 30. So it's like saying, how many times do I have to take 4 times itself to get 30? Well, 4 to the first power is 4. 4 to the second power is 16. 4 to the third power is 64. But it will never hit 30 exactly on the nose. 30 is going to live somewhere in between those two. So I'm going to get a decimal number that's somewhere between 2 and 3, okay? But let's say my calculator doesn't evaluate log base 4 of 30, okay? I can't just type that in. What I can do is I can change the base. And I can change it either to base 10 or I can change it to base E, which is ln, okay? And both of them are the same way. If I change it to a base of 10, it's going to be log base 10 of something over log base 10 of something. This number right here goes to the top. The basement number goes to the basement. Okay, so the subscript number always goes below. So I just do log base 10 of 30 over log base 10 of 4, and I will get an answer. Okay, typing that into my calculator. I have a dumb calculator. So I'll do log of 30, and make sure you close your parentheses, otherwise it will screw everything up. Notice that there's no number here, but we already talked about how that number is 10 if there's no number. So I do log base 10 of 30 divided by log base 10 of 4, and that gives me 2.45. Okay, so 2.45. Now, it would have been the same if I would switch them both to ln's. It would just be ln of 30 divided by ln of 4. Okay, let's see if we get the same answer. ln 30 divided by ln 4, 2.45 again. Okay, so it doesn't matter which one you switch to. You can switch to a base of 10. You can switch to a base of E, which is ln. It doesn't matter. Or, some of you guys' calculators will evaluate it without doing that. But this is how you can switch it if you ever need to. Okay. All right. Properties of logs. Property number 1 says multiply equals add. Okay, in log world, multiplying and adding, you can break logs apart or put them together by multiplying or adding. So if I have one log, notice that there's only one log here, but I have two numbers that are multiplied together. If I want to split those up into 2 logs, I would add in between them, okay, or vice versa. If I have this, I can then consolidate them to be those 2 pieces with this one multiplied by that one. So multiply means add, okay? Now, in addition to that, I have divide, which means subtract. So if I have log base something of something divided by something, which is my division, okay, I can separate those into 2 logs, but then I'm going to subtract in between them, okay? So subtraction and division go together hand in hand in log world. This column over here is not anything different than that. It's just saying ln works the same way. So ln of uv would be ln of u plus ln v, because multiply means add. Okay, ln of u divided by v is ln of u minus ln v, minus because it's divide. Okay, now this part number 3 here, I'm going to use some actual numbers here. Let's say I have like log base 2 of 10 to the 3rd power. Okay, what these 2 properties allow me to do is anytime there's a log there, I can move this 3 or whatever that exponent is down in front. Okay, so instead of log base 2 of 10 to the 3rd power, it's 3 log base 2 of 10. All right, now I'm going to write out why that is, okay? Let's say I have log base 2 of 10 to the third power. This is really kind of interesting the way that this works, okay? This is the proof of why it works, all right? 10 to the third power is just log base 2 of 10 times 10 times 10, right? That's what 10 to the third power means, 10 times 10 times 10. But then what I can do is multiply means add, right? So that just means log base 2 of 10 plus log base 2 of 10 plus log base 2 of 10, right? If I separate them into 3 pieces, I'm adding in between them. And then how many log base 2 of 10s are there? There are 3 of them. 3 log base 2 of 10s. If I combine like terms, adding this one together, that's 3 log base 2 of 10s. So I can go from here straight to here by moving that 3 down in front. So this is just kind of a proof of why that works. I always remember that when I go through here, and I can just kind of see that. Now, what people try to do is they try to do illegal things like moving exponents down in front when there's not a log, okay? So like, let's say 3 to the x power. I can't just take that x and move him down in front and make that x3 or 3x. 3x is not the same thing as 3 to the x power, right? It only works if there's a log in front of it, okay? All right, so, and it's the same thing with ln. If there's an exponent, you can move that exponent down in front for ln, okay? So write each log in terms of ln of 2 and ln of 3, okay? So they want us to write 6, ln of 6, in terms of 2 and 3, okay? So ln of 6, I can say, is ln of 2 times 3. I can write them out like that, but then multiply means add. So this would be ln of 2 plus ln of 3, and I have just written that in terms of ln2 and ln3, okay? This one here, I have ln of 2 divided by 27. Well, what the heck is the 27 coming into play? Well, let's do this. Let's do this. I have, if I separate those two, division means subtract. So I can first say ln of 2 minus ln of 27, right? Division means subtract, so I'm subtracting those two. And then we're going to kind of break down this 27 just like we did with the 6, okay? This guy is going to be ln of 3, and we can write that as 3 to the third power, I guess. That would be kind of cool. And then we can bring that 3 down in front, right? So ln of 27 is 3 to the third power, which would be 3 ln 3. And then I just put my ln2 in front of it. So this would be ln2 minus 3 ln's of 3. That's what he would look like. Okay, so now we have him in terms of ln of 2 and ln of 3, and we can write him that way. Okay, so there he is done. All right, now they want us to expand this thing and this one, and then the next two problems they're going to have us put them together, and then we'll be done. These expanding ones, though, are kind of, I think they're kind of fun, but some people get really confused when we're doing these, so be careful. I have this, and I'm going to put him in parentheses. That's what I'm taking log base 4 of. Okay, so this is 5x cubed y. Okay, now this, another way of writing this is 5 times x cubed times y. So I am multiplying each one of those things together, and multiply means add, right? So I have 3 pieces really that I'm going to add together. I have log, I'm going to start all the way over here because I have a long one. Log base 4 of 5 plus log base 4 of x cubed plus log base 4 of y. Okay, and then there's one more thing that I can do. Since I have this exponent, I can move him down in front. Okay, and I'm going to rewrite the whole thing. Log base 4 of 5 plus, this would be 3 log base 4 of x plus log base 4 of y. And that's what he would look like after I expand him. Okay, so kind of a long thing, but that's okay. Now, keep in mind that if you are, I'll go down here to like the condensed ones, you cannot condense them if they're a different base. So this one would have to be log base 10, and that would have to be log base 10. They're not going to ask you ever to do, or I'm not going to ask you ever to do anything where you're trying to put 2 logs together that are different bases, but that's just kind of how those things operate. Okay, so this one, ln. All right, so this one's going to be kind of tricky. I have division, so I'm going to subtract. So let's do that first. So I'm going to say ln of the square root of 3x minus 5 minus ln of 7. Okay, so that's what he's going to look like. That's the division. I have separated them out and put a minus sign there. Okay, now This guy, the square root of 3x minus 5, I am going to write that to the 1/2 power. Okay, that's what the square root does. And then that 1/2 power I can move down in front. And I have 1/2 ln 3x minus 5 minus ln of 7. Okay, now at this point people get kind of stuck because they're like, well, then I can take the 3x and I can, separate those out into two pieces and add in between them because 3 times x, right? Well, actually the 3x and the minus 5 are attached to each other, okay? So really this is all the farther that you can go, okay? It doesn't work the same way when you have a minus in here. I can't switch this to like ln of 3x divided by 5. That's not the same thing because minus would be if there was two ln's subtracting each other and you were putting them together. That's what this would be. So in order to get here, it would have to look like ln of 3x minus ln of 5. And that's not what this means up here. That's not what that is, okay? So really, this is all the farther that I can go because the 3x minus 5 is trapped together, okay? This is not the same thing, okay? So now we're condensing, last thing. Condensing, we have two pieces, this one and this one, and I want to condense them, but I want to get rid of the exponent or the number out in front first. So this 1/2, I can move him to the back and make that x to the 1/2 power. So now he's gone. This 3 I can move to the back and make that x plus 1 to the 3rd power. Okay. Now before I put them together, x to the 1/2 power, I'm going to write that as the square root of x before I put them together. Okay, x to the 1/2 is the square root of x. So I have log base 10 of the square root of x plus log base 10 of x plus 1 cubed. Okay, and notice that there is a plus sign in between them. Plus means add. So if I create just one log, okay, I'm going to, plus means add. Plus means multiply. I'm going to multiply them together. So I'm multiplying this square root of x times the x plus 1 cubed. Okay, and that's what he would look like. If you want to, if it makes you feel better, put brackets around that so you know it's log of that whole thing. But that's what he would look like, and that's how you would condense him. Okay, all right, now this one. I have two ln's that I want to put together and separated by a minus sign, but the thing that I want to move first is the 2. I'm going to put the 2 to the back, okay? Do not FOIL this out. X plus 2 squared, you don't need to FOIL it out. Don't worry about doing all that. Just leave your answer just the way that it is. So I have ln of x plus 2 squared minus ln of x. The minus means divide, so when I put them together, I'm going to have some sort of division. The top is going to be x plus 2 squared, and the bottom is just going to be x. Okay, now don't try to cancel. This is like an algebra thing. Don't try to cancel those two x's out because this one is trapped. So this is going to be your final answer. That's what you get at the very, very end. Okay? All right, so all of this stuff should be kind of review, yeah, we're just flying right along through logs.